Good afternoon, class. Here's Module 5 covering chapters 10 and 11. Here's chapter 11, sequences and series. Chapter 11, sequences and series. Write the first 5 terms of the sequence A sub n equals 9 times 1/4 to the power of k minus 1. Simply put, replace the k with 1, 2, 3, 4, 5. So if you replace it with 1, you get 0 here. 1/4 to the power of 0 is 1. So we get 9. Replace the k with 2. This is 1. 1/4 to the power of 1 is 1/4 times 9 is 9/4. And basically you're multiplying 9 by 1/4. And then 9/4 by 1/4. 9 over 16, 9 over 64. As long as you can show work for a couple of items, the first couple of terms, that means you should be able to finish the rest. For this sequence, a sub n is 2 sub a sub n minus 1 plus a sub n minus 2. A sub n equals 6, a sub n equals 3. We want to find the first term, of course, is given is 6, a sub 2. This is 3. So these two are given, the first and the second term. So in essence, we are working on part C, D, and E. The first two are given. So what is the meaning of this? If you want a term, multiply the one before that by 2, and then add that to the one before that. So for example, if I want, so here's the definition first. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given, and f is a real valued function. A solution is a sequence, a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. So when a sub n is this, and we have a sub 1 and a sub 2, we want a sub 3. So 2 times the one before that, a sub 2, and then the one before that. One way is to say if this is 3, that makes n equals 3. This is 3 minus 1 makes it 2. And this is 3 minus 2 makes it, if you want to work it out. But in any event, I think it's very straightforward that you want to tear, pick the previous one times 2, and then the one before that. So before a sub 3 is a sub 2 times 2, that means 2 times 3, and the one before that is 6. 6 and 6, 12. We're going to use the same formula, and now we're going to go with a sub 4. If this is 4, that means 2a sub 3 plus a sub 2. So that means 2 times 12 plus a sub 2, 3. 24 plus 3, 27. And I'm going to leave the last one for you to figure out in the same manner. So we are ready to move on. Determine whether the sequence is arithmetic, geometric, or neither. If the sequence is geometric, find the common ratio. Recall. What is an arithmetic sequence? Recursively, a sub n plus 1 is a sub n plus d, or explicitly by a sub n equals a sub 1 plus n minus 1 times d. In other words, there is a common difference or distance. On the other hand, geometric sequence, recursively, a sub n plus 1 is r times a sub n, and explicitly means a sub n equals a sub 1 or to the power of n minus 1. So if there's a common difference or distance is an arithmetic sequence, if there's a common ratio, it's a geometric sequence. So one way to find out, you look at their difference or their ratios. In this case, we are interested in both. We notice if we divide the second one by the first one, meaning a sub 2 divided by a sub 1, we divide these two and we get negative 2. Now, that doesn't mean it's a common ratio. It means this is the ratio of the second one to the first one. If the rest of them work, then we are fine. So we're going to look at a sub 3 divided by a sub 2. So let's actually write this at top of it. So this is a sub 1, a sub 2, a sub 3, a sub 4, and a sub. So let's divide a sub 3 by a sub 2. We get the same answer. To be honest with you, you really should check more, but that's good enough. They are the same. That represents a geometric sequence with r being negative 2. That's the meaning of this. So we checked two of them. Over here, if we divide 8 by 6, it's not the same as 11 over 8. So this means, again, let's just say this is a sub 1, a sub 2, and so forth. So this one would be 8 over 6. And this one would be 15 over 11. And their distance is not the same either. In other words, take a look. The difference is 2, the difference is 3, and so on. Therefore, it's neither geometric nor arithmetic. Over here, let's divide 1/2 by negative 2. Again, this is a sub 1. This is a sub 2, and so on, right? So if I divide a sub 2 by a sub 1, and if I divide a sub 3 by a sub 2, so 1/2 over negative 2, and negative 1 over 4, both of them are the same, negative 1 over 4. If I divide a sub 3 by a sub 2, meaning negative 1 over 8 over 1/2, I get also negative 1/4. That means this is a geometric sequence. Write the arithmetic sequence 32, 24, 16 in standard form and find a sub n. Again, arithmetic sequence means this recursively and explicitly. We've seen it. And so, in other words, we want to find a sub n. In other words, we want to use this formula. And so what is the first term? 32. So a sub 1 is 32. What is their common difference? The distance, 24 minus 32, or 16 minus 24. Both of them result in the same number, negative 8. And now we are going to use this formula. And we're going to plug in A1 is 32, N minus 1, D is negative 8. So You distribute, you get minus 8n plus 8. These two add up, we get minus 8n plus 40. So a sub n is minus 8n plus 40. That's very straightforward. Hopefully everybody is okay with this, so we can move on. Filling in the blank, 139 is which term of the arithmetic sequence 1, 4, 7, 10, etc. Well, we are going to use this and eventually find the n. So what is the first term is 1, the difference is 3. So the first term is 1, 4 minus 1, 7 minus 4, 10 minus 7 is 3. So we're going to use that. So plug in and observe. We're going to replace the a sub 1 with 1, n minus 1 times d with 3. And so we get 1 plus 3n minus 3, 1 and negative 3, they add up to negative 2. So we have a sub n. Now we set that equal to 139. If we set this equal to 139, we can find n. Move the negative 2, positive 2, 141 divided by 3, n is 46. Okay, so it's the 47th term. It's pretty straightforward. Find a formula for the general term a sub n of the sequence, assuming the pattern of the first few terms continues. If this continues, that means first you've got to figure out what type of a sequence are you dealing with. That's the first thing that you have to figure out. Well, the first term is 0.8. Therefore, we have to either find D or R. It may be a common difference, makes it an arithmetic sequence, or maybe a common ratio. It seems to me the difference is not that good. So let's look at a sub 2. This is a sub 1. Let's write a few of them. A sub 1. This is a sub 2. A sub 2. So let's divide a sub 2 by a sub 1. 4 divided by 0.8, that means 40 divided by 8, that means 5. 40 divided by 8. Okay, so that's very straightforward. And so, since they mentioned the pattern follows, you really don't have to, but if you divide 20 by 4, you get 5. I hope you see that. Okay. And so that's why we did this ratio and this ratio. Okay. We did two of them just to make sure that uh, they are the same and they happen to be the same. So that indicates that we are dealing with the geometric sequence. The first term is 0.8, the common ratio of 5. So the general term, we go with that formula, a sub n equals a sub 1 r to the power of n minus 1. So that means plug in 0.8 and 5 to the power of n minus 1. Now, what is a sub 8? Well, you can, of course, continue in that manner, but it's easier just to replace the n with 8. So a sub 8 is a sub 1 r to the power of 8 minus 1, which is 0.8, 5 to the power of 8 minus 1, which is 5 to the power of 7. Putting it into a calculator results in 62,500. Find the ninth term of the geometric sequence whose initial term a sub 1 equals 4 and the common ratio is 2. So obviously we're going to use this formula. Replace the a sub 1 with r and r with 4 and r with 2 and n with 9. That's all. So a sub 9 is a 4, r which is 2 to the power of 9 minus 1 which is 8. So 2 to the power of 8 times 4 becomes 2 to the power of 10, just in case. So this is 8. This is 2 squared. So I hope you see this is 2 to the power of 10, just in case. Okay. Very straightforward. We have the answer and we're done. Evaluate summation of k squared minus 1 from 3 to 7. Simply put, it means plug in 3. That means 3 squared minus 1. Plus plug in 4, plug in 5, plug in 6, plug in 7, square it minus 1, adding. That's the meaning of it. So start from 3, 3 squared minus 1 plus 4 squared minus 1 all the way to 7 squared minus 1. 9, 16, 25, 36, 49. Do the math, add them up, and it's 130. So it's pretty straightforward. Write the arithmetic sum using sigma notation, 9 plus 4 plus -1 all the way to -26. And we remind everybody recursive format a sub n plus 1 is a sub n plus d, and explicitly is a sub n equals a sub 1 plus n minus 1 times d. So what this means is you have to find a sub n, and then you write the summation going from n equals 1 to whatever this one is, the fourth one, the fifth one. We're going to figure all of them, but that's the concept. So write the summation of n going from 1 to n a sub n, find a sub n and n. That's the methodology. So they mention it's an arithmetic sum. Of course, notice that you add -5, or you can say you subtract 5. So 9 minus 5 is 4, 4 minus 5 is -1, and so forth, which means the first term is 9 a sub 1, and these 4 minus 9 or -5. So we are ready to move on. We are going to put 9 instead of a sub 1, -5 instead of, to find a sub n. So we distribute here, we get -5n plus 5. And of course, 9 and 5 add up to 14. We have -5n plus 14. So we got this piece. But what is this? What is n? Well, the last one, we don't know which term it is. So we put it into this. In other words, we set it equal to this to find the n number. So a sub n is -26, the last one. And it's -5n plus 14, which means when I move the 14, subtract it, we get -40. Divide by -5, and n becomes 8. By the way, n has to be a positive number. If not, we have made a mistake somewhere. I can't emphasize this enough, okay? And that's the final answer. Notice we have this number, we have this. Evaluate the summation from 1 to 14 of 3 times 2 to the power of n minus 1. Well, again, the meaning is replace the n with 1, evaluated, plus with 2, evaluated, and so forth. That's the meaning of it. Okay, so if I plug in 1, I get 0, 2 to the power of 0 is 1, so I get 3. If I put 2, I get 2 times 3 is 6. If I put 3, 3 minus 1, 2, 2 squared is 4 times 3, 12. So I hope you see that we get this, which is obviously a geometric sequence. And by the way, this is a format of a geometric sequence, okay? A sub n. And so the first term is 3, and R is 2. We're going to put it into this formula. Replacing the a sub 1 with 3 and R with 2. Now, what is n? 14. So we want S sub 14. At this point, you have to plug it into a calculator, which means 2 to the power 14 subtracted from 1 times 3 divided by -1, you get 49,149. You have to put it into a calculator. Find the partial sum S sub 11 for the arithmetic sequence with A sub 1 being 9, D being 3. When we have the first term and the last term, we use this one. When we don't, we use this formula. So S sub n is 2, A sub 1 plus n minus 1 times D. And so A sub 1 is replaced by 9. D is replaced with 3. N is replaced by 11. All right, so 2 times 9, 18. 10 times 3, 38. 30 and 10 is 48. 24 times 11, 260. So that's called the partial sum because it stops at some point, the 11th term. Any number that stops, it's a partial sum, unless it goes indefinitely and forever. It continues indefinitely, then it's no longer a partial sum. Okay, find the infinite sum if it exists for this geometric series. Let's remind everybody first then that this is S sub n. If n is any number is considered finite and it's considered partial sum. However, if n is infinity, then that's what infinite sum means. Now, it's going to be difficult to calculate it unless r is between -1 and 1, in which case r to the power of n goes to 0. And you can try it if you have a fraction like 1/2 or 1/3. When you raise it to the power, it becomes smaller and smaller. So we call it sum S sub infinity. That means infinite is A sub 1 over 1 minus R. So first and foremost, the first term is -2. We want to find R. To find R, you divide this one by this one, this one by this one. And as long as R is between -1 and 1, then we can use that. So R is 0.5 divided by -2, which makes it -1/4. If you divide this one by this one, you get the same thing. And needless to say, the reason you don't have to check it because they mention it is a geometric series. That's what they say. So you don't have to check it then. So when R is between -1 and 1, we use this one. And therefore, S sub infinity is A sub 1, which is -2, divided by 1 minus -1/4. This one is plus, makes this 5 over 4, and -2 over 5 over 4. I hope you recognize this as -2 over 1, 5 over 4. So this is -8. This one is 5. So -8 over 5 is the final answer. Find the infinite sum if it exists for this case. You may recall that we did this in the beginning and we got, if you plug in 1, you get 1 here, it's 9. If you plug in 2, you get 1/4 times 9, 9/4, and then 9/16. So we had this before. We had calculated the first 5 terms, if you recall, from the first question. And so we know it's a geometric sequence with the first term being 9, and R is simply 1/4 if you multiply this by 1/4, this one by 1/4, and it continues. Because this 1/4 is a number between -1 and 1, we can go with this formula. So let's plug in. So what happens when we plug in? This is 3/4. 9 divided by 3/4 is 9 times 4 thirds, 36 thirds, or 12. Pretty straightforward, everybody. Application. On each swing, left to right or right to left, a pendulum travels 90% as far as on its previous swing. If the first swing is 10 feet, so we go from point A to point B and come back. As we move, due to friction, it slows down, but it takes some time. So that's why it goes 9 when it goes and come back, it loses about 10%. So 90% as far as the previous swing. If the first swing is 10 feet, determine the total distance traveled by the pendulum before coming to a complete stop. And again, this is a geometric sequence. Think about it. If the first one is 10, then the first one is 10. A sub 1 is 10. And R is 0.9 means 10, 9, and then 0.9 times 9, 8.1, and so forth. Okay, that's the meaning of it. So we use the formula S sub infinity is A1 over 1 minus R. A sub 1 is 10. 1 minus R is 1 minus 0.9. As you know, 1 minus 0.9 is 0.1, and 10 over 0.1, that means 10 times 10, 100. And you use the units feet. Because anytime you're dealing with the application class, if units are given, you give them back with proper units, always. A ladder consists of 31 rungs if the rungs taper uniformly from 18 to 28 inches. That means uniformly it's 18 and it becomes larger and larger and larger until it gets to 28 inches. And there are 31 of those. How much material would be needed for the 20th rung? So the concept is very simple. You have a ladder, and this is smaller, and the last one is the largest. That's the idea. And the total is 31. So n is 31. It's AS, arithmetic sequence. N is 31 because they said so. The first one is 18 inches. The last one, that means A sub 31. The last one, that means A sub 31 is 28 inches. And what is A sub 20? That's what the question is all about. So we use the general form a sub n, for a sub n, which says a sub 1 plus n minus 1 times d. And what we do, we really have two equations, two unknowns. Take a look. These two give us two equations, two unknowns. So we can find the first term. In this one, the first one, a sub 1 is given, 18. So we can actually, we don't, okay, and we can use a sub 31 to find the missing d. So a sub 31 is a sub 1 plus n minus 1, 31 minus 1 d. And a sub 31 is 28. A sub 1 is 18. 31 minus 1 is 30 d. Subtract 18. You get 10. Divide by 30, you get 1/3. So that's very straightforward. We got the D, and now what is A sub 20? We use the same formula again. A sub 1 plus n minus 1 times D. This time, for 20, we use n equals 20. Plug in. A sub 1 is 18 plus 20 minus 1, 19 times 1/3. Of course, this is 19/3. Or 6 and 1/3. 18 and 6, 24. 24 and 1/3 of an inch. So that's pretty straightforward. How much material would be needed for all of these 31 rungs? So we want S sub n, we can use either this formula or that formula. The first one and the last one are known, so it's easier to use this formula. Again, the reason we use this formula because the first and the last one are given. Just plug it and observe that this is 31 halves, this is 46. 46 can cancel out the 2. 23 times 31, 713. Units, always proper units. Look at the units here, right? So you know where the units come from. It's important to write the proper units always, as it's the case here, for example. The factorial symbol, recall n, if n is larger than or equal to 0 is an integer, the factorial symbol n factorial is defined as follows. 0 factor is 1, 1 factor is 1, and n factor is n times n minus 1 all the way to 1, n is larger than or equal to 2. Of course, n factor is n times n minus 1 factorial. What this means is that you can start with n and stop anywhere and put a factorial, unless you end up with 1. For example, if it's 10 factorial, you can say 10, 9, and stop at 8 and say 8 factorial. That's the concept. Combination. There are 3 different ways of writing it, and it means n factorial over r factorial times n minus r factorial. If you want to simplify, of course, by hand, it's very simple because the bottom is 10 and smaller than 12. You keep the bottom as 10 factorial and the top is 12, 11, 10 factorial. This is what I was explaining here. And you can get rid of these two. 12 times 11 is 132. The binomial theorem, we have already discussed that. So if you have, and if you recall x plus y or x plus a to the power of 2 to the power of 3 and so forth, those are binomial. So it uses a combination. The first one is n0, x to the power of n. The next one is n1, a to the power a, x to the power of 1, in this case, times x to the power of n minus 1, a to the power of 1, and so forth. It's easier if we, for example, remember a plus b squared is this. A plus b cubed is a cubed plus 3ab, a squared b plus 3ab squared plus b cubed. And in general, we have n factorial over r summation of n factorial over r factorial n minus r factorial x to the power of n minus r, a to the power of. And we start with r equals 0, which means the very first term has the power of n for this one and 0 for this one. So the first term doesn't really have a. That's the meaning of it, as you can see here. We've already discussed that. I highly recommend you try those. It's really helpful, and it makes it easy when we want to calculate this. For example, n0, the same as nn, and it's equal to 1. n1, this is 1, and if you know that's the one before that, if you know that's n, the one before that is also n by this theorem in essence. So we have those formulas, and we want to use it to expand this. Following that. So 4, 0, 3y to the power of 4, which really means 1 times 3y to the power of 4, 1, 3y cubed times 2, 4, 2, 3y squared times 2 squared, and so on. That's really following that. And what is important for everybody to know is the following. This is 1, this is 4. This is 1, this is 4. The reason why, look at this, 2, they add up to n, okay? That's the formula that was mentioned before, okay? That's the formula that was mentioned before. That really speeds up the process. So the only thing you have to calculate is the middle term, 4, 2, combination of 4, 2, and that's 4 factorial over 2 factorial times 2 factorial. As you know, this is 1, 2, 3, 4. By the way, 2 factorial is the same as 2, so it becomes 4. And so the answer is 6. So you are going to replace those. But don't forget that this one, everybody, the 3y to the power of 4 gives you this, because 3 to the power of 4 is 81, y to the power of 4. 3 cubed is 27, y cubed, and so on. Now, you multiply, that means this is equal to 81 y to the power of 4. You multiply 4 and 2 and 27, you get 216 y cubed, 6, 4, and 9, you get 216, so on and so forth. That's the expansion. Okay, everybody? Find a specific term, in this case, the 7th term in the expansion of y plus 3 to the power of 8. If there's time, we do that. We have time, we're going to go over that. And let's see how we approach that. So we use that. An easy way out, there are some formulas, okay, that we can use, but the easiest way is to notice the first term r is 0, the second term r is 1, the third term r is 2, and so on. So the seventh term r must be 6. That's the idea. So this means combination of 8, choose 6, and replace the r with 6. Based on the expansion, this is what the term containing x to the power of j is n over n minus j, a to the power of n minus j, x to the power of j, and so forth. That's basically that's what we are saying here. So the rth term is using that. And so 8, 6. So you go with this methodology, it's a lot faster. Y to the power of 8 minus 6, which makes it y squared, and 3 to the power of 6. So, and this is 8 factorial over 6 factorial times 2 factorial because you're using the combination, and you end up with this one being 8 times 7 times 6 factorial. The reason you do it that way because you want to get rid of this 2, and this gives you 4 times 7 times 7, 29. It gives you 20,412 y squared.